Now we're going to do a more classical approach, and therefore it's going to be very, very boring, right? Because what I'm going to do now is I'm going to talk about, solving problems and using this kind of technology. I'm going to do demos that hopefully works. But then again, it's that's what you guys are used to, right? It's a technical thing. Whew. So I hope you guys had at least some oxygen in here, because yes, it's next thing is lunch. So I planned for 45 minutes. I timed myself yesterday, had 1 hour and 20 minutes, and I have 1 hour now. So let's see where we end up. I work for a company called Permobil. Permobil is, it's one of those companies where we are what we make. Everyone knows what a Permobil is. It's based in Sweden. We make electrified wheelchairs, and we believe honestly that people are not defined by their disabilities, which was evident this morning as our sponsor team on DreamHack actually slayed their first opponents in CSGO on DreamHack, which I feel is more perhaps to this crowd. There are computer game players. You guys look like a bunch of right now. All right, never mind. Who am I? My name is Mikael. I'm one of those architects that Barry talked about who just did a couple of very, very good things, and then, that took me somewhere. I found BizTalk, and I did 10 years of BizTalk, and that pretty much took me where I am today. So I've been doing integration since forever. I've been on Azure. I have an Azure account since 2009, which I kind of feel is kind of cool. And also, I've been an Azure professional since 2015. I've been working working as a consultant up until August this year, when I moved to Permobil. So all of these things which I'm going to show you and talk about is, of course, not only experience on my current situation or current employer, but also all the other guys that I work for, right? So everyone understands that. So we're going to talk about API. Yeah, I added that for giggles. We're going to talk about APIs or API security, and I'm going to say a lot. I'm going to say the word APIs or API platform a lot. So therefore, I'm going to start by defining what do I mean when I say API platform. What is it? And of course, everything is super duper Azure based, right? So this is the most basic thing you have when you have an API. You have a calling service. Let's see if the old thing works. There we go. You have a caller. You have some kind of functionality. HTTP trigger function works quite well, actually. And you call some kind of backend service of data. That's the basic level of APIs, right? But as you start working with APIs, you also realize that this is kind of good, and you need more APIs. You have more functions. You use something called a logic app, which calls out to an external service. And all of a sudden, you have a lot of APIs, and you start to realize that you need some kind of manager for this. So enter the service API manager. That's kind of what we have. And you can see that this is kind of a layered approach, and yes, this it's intentional. It's a layered approach. So you have on the top layer there, you have your user, who usually handles things like authentication, and then you have your so-called experience layer, which is the Azure API manager, or APIm for short. And then you have your processes, your development, your code, your functions, everything is here, and then you hide data or the external services in the backend. And sometimes you have the word system APIs here and so on. I'm mainly going to be focused on this product or this layer, and I'm going to talk a lot about this. So now everyone knows where we are and what a platform is. And I'm also going to show this thing a lot. So, this is once again basics. What do? You have a caller who calls the API manager. It doesn't call your function, it calls the API manager. And the function then calls your backend service. The service doesn't call your backend database. That's the thing. We have different layers. Everyone's, on board with that. So it's time to scare you a bit, because this is, it's supposed to be a talk about security, and you can't do stuff about security without one, telling an anecdote of some people being stupid. That's one way of getting through to you, and then the other way is to scare you. And I'm going to scare you. I'm going to talk about something called hijacking. What is hijacking, and how is it related to hacking, other than semantics? Well, it's basically this stuff. People have been using APIs and API keys forever. As their sole mean of protection, you have a key in front that you use with your API. Someone submits that API key and they get access to your API. Everyone's happy, right? However, these tend to be, they get lost. People copy them, then put them in. This thing here is actually not a Python exploit. Someone used Python to query the Wayback Machine to find API keys in configuration files and started, pulling them out of there and found about 10,000 of them. I mean, it has to be something valuable in there, right? So don't store your API keys in clear text in configuration files. That's number one, right? Sure. So hijacking is basically someone stealing your authentication API key and using it because you have no ability of knowing, is this actually the caller, right? So how do I beef up my API security resiliently? I'm going to talk a lot about layers. So I'm going to walk through the layers. So you have your service. In this case, you have like a very nice, let's call it a coffee service or whatever. A very nice guy that works as a barista or whatever. This is not an actual thing that I'm going to build. It's just a metaphor. And everyone's usually nice, and then some, Karen kind of type turn up, who has worked in services before they became an IT. Yeah. Everyone knows who this person is, and the only thing we can do to protect ourselves is to put up different, protections, walls, layers. And these are the layers that I'm going to be talking about today, given, starting off by, like I said, the key, and then I'm going to talk something called an application gateway. I'm going to walk a bit through a firewall, and I'm going to show you how powerful logging can be. And in the end, we're going to do the hardest thing because I want to rush this part because this one is important. And it's just before lunch. So we're going to talk about OAuth as well. So I'm going to rush through API keys because everyone knows what an API key is. If you don't, it's very easy to Google it. There is a very good list of pros with the API keys. Number one, it's very easy to use. Here's your key, start to use it. Send it to me when you call it. How many in here send the API key in the address? No one wants to do that. Don't ever do that. You could do that. API management out of the box supports that. Don't ever send the API key as a part of the address, as a query string. Always use the headers. There are reasons for that. If you need to recycle it, the user can recycle it him or herself. Just log in, ask for a new key, everything's recycled, you don't do anything. Right? Good. Cons, a couple of them, of course. It's a shared private secret. If you steal my API key and use it on your API, he has no way of knowing if that call is yours or mine because it's a shared private secret. It's a very bad thing. It's in clear text. One photo, all it takes. Good, it's there. So the problem is that it's shared, basically. But moving on to the next thing is then, of course, the so-called application GW, or the application gateway. Which, if we go back to this thing, where does it fit? Well, it fits right here. It places itself in front of the API management thing, at least in this layered architecture thing that I'm trying to show you. That's where it is. What is it? It is an Azure native service-based gateway. What is a gateway? Well, a gateway can do simple things like simple load balancing, for instance. It can identify a couple of instances of your services and basically do a round robin and say, every fourth call comes to that place, which is good, but it's not what you usually want from a load balancer. If you're doing a load balancer thing, you can use something called the Azure Front Door, which is kind of basically the same, but a much better load balancer. And it's an all or nothing approach because it's a gateway. So either your call gets through to the backend service or it doesn't. It's not a, kind of sometimes it does, or every third goes to North Europe and every third goes to America. It's not one of those things. It's just an all or nothing gateway thing. And you can make this part of your infrastructure. You can make this gateway be the front of your company because you can give it a certificate, a so-called PFX identity, PFX certificate, sometimes called a star certificate. So when people call your API, it looks like it's like on your place, right? So I'm going to do a hopefully quick demo about it. And let's see here. I haven't done a demo live for 2 years, so I'm super duper excited for this. I'm not going to provision a gateway or even an API management thing live because an API management thing takes about an hour. The gateway is not as well. So let's see. You guys at the back, you have to trust me on what I say instead of just trying to read off the screen. But please let me know if I, point to something and you need me to shout out what it says. A gateway consists of a lot of different things. You have so everything is HTTPS based, which means we have things like words like requests and responses and HTTP status responses here. So you get a thing at a glance on like how is your gateway doing, right? That's the first thing. And what you do is that you define what's called a listener. And this listener is defined in this particular case to listen on port 443. I had a developer who didn't know about ports. Yes, it was not me. So it listened on my public IP address on port 443 using this certificate. So it identifies itself as being part of permobil.com. So when you call me, you trust, you have a proper certificate and everything's up and running and so on and so forth. So every call gets to this listener, and now we get into the more shady parts of the Azure portal when it comes to things like layout and usability. So, even though if you were here, you still couldn't read it. So what it says here is that you have rules, and you have what's called a routing rule. And this routing rule, let's go over here instead, is what Portal's saying now. It's basically saying, okay, I have a couple of rules which is connected to this listener. If one of these rules is executed, it points to what's called one of these backend pools. And a backend pool is your instances. So whatever it is you're using, in this particular case, one API management thing. And then you have something called a sink. And a sink is a default. If someone doesn't fulfill the routing rules of API management, you get pointed out into infinity. So you get back a 502. So this basically is, like I said, it's a gate. If you have an API that's called, in this particular case, shared/weather, you can call it, but if someone tries to call weather, it gets back a 502, and it doesn't even touch your API management instance because it gets stuck here. So I'm going to very quickly show you this, hopefully. So let's see, we have this call API here. I have a thing called shared weather, which is you send in send in a city, and you send in either CNF to get Celsius or Imperial, and it responds back with the current temperature. In Stockholm right now we have -2, but it feels like -4 because of reasons. If I were just to show you that someone just trying to hammer something through, they get back this instead because it's behind the gateway, it's blocked. So it's not very hard. That's kind of the basic thing you do. So let's see if I could do the same thing that Mohammed did so well. Yep. This part takes forever on my machine. All right, sure. Next step. Sorry, so we just went to the application gateway, but we also have a firewall as well. And what is this firewall? I have no idea what's happening right now because it has another picture right there. So I'm going to read off of here. It's an extension to the gateway service. So if you have the gateway service, you said, hey, I want the firewall as well. Microsoft says, give us a little bit more money, and you say yes, and everything works. Super simple management. I am not a network guy. It was very easy to set it up. And you can have logging via Azure Monitor. I will show a bit later why that's a very good feature. You can put on something called message validation or message inspection. So what this basically means, because now we're working on what's called the layer, I think 7, on because of the web application firewall. So if someone sends in a message and it says content type application/JSON, it looks at the message and validates it to look and say, is this valid JSON or is this valid XML? Which is super duper good, because one of those things that you do when you're a hacker or you're trying to do an overload thing is that you send poison messages. You send malformed stuff, which your backend system, we're talking about resiliency earlier, right? They have a bit of a problem handling these things because they don't really know what to do with it. And everyone knows that if you get an error within your system, it's much more complicated to handle that. So it's usually, more cycles of the CPU and so on. So therefore, it gets stopped all the way up here, which is super useful. It also supports what's called the OWASP rules. And then, of course, everyone wonders, let's see if it works. Yes, what is OWASP or OWSAP? It's not white Anglo-Saxon Protestant. It stands for something else. It stands for Open Web Application Security Project, which is basically guys and girls, much like us, that have identified a couple of issues and are trying to mitigate these issues by elevating people's awareness of security on the internet. It's a non-profit organization. Everything is super open source, and they have what they call their famous top 10. Their famous top 10 list is, this is, you're not supposed to read all this, but it's a list where they list the top 10 things that you can do to secure APIs or websites. The very simple things, because these are actual things that people out there are trying to do. Now, the very cool upside of this is that they publish their results as open source. And Microsoft says, very much thank you, and they implement this into the web application firewall, which means I can have all these things. Someone much better than me can figure all these things out and say, you need to protect yourself against something called cross-site scripting. And I'm like, all right, I have no idea what it is, but I trust you. And I can just check a box, and it's there. So the firewall fits here. So let's very quickly go through the firewall. Let's go through the firewall. It sounds like we're doing something really, really bad. My computer is not that quick because it's a very old Lenovo and it's heavy as F. You can use it as, someone follows you home that you don't want to. You can hit it with them. They're never going to rise up again. Okay, sure. Here's the firewall. Let's see if we can configure the firewall together. Well, you slide this to enabled, you're good. You're protected. That wasn't that hard, right? You can set the firewall to either detection or prevention. Of course, you want prevention. Detection is something bad happened, but I let them through, which is very not useful at all. And then you have this thing here called rules. And here's where we have the OWASP. So what you do is that you say, I want the OWASP rules, and I want version 3.0. These are mostly related to people running Java backends, so I don't need it. And then you can do things like very custom rule configuration. If for some reason you realize that this rule messes things up, you can remove it. And simply say, well, don't scan for that, because my users, they F up all the things, and therefore, And going back to configure, this is how you turn on the request inspection. You slide this to the right, and this is like the only, I would say, pretty poor limitation of this product, is that the maximum size of the body that can be inspected is 128 kilobytes, which is not a lot. And it's a global setting, so that means that it either scans every message or no message. I've been talking to them about this. I see this as an issue. It should be at least 512 kilobytes, and then, trying to make people use uploading or chunking instead, because then you can have this one. So let's do a super quick demo about this. So in order to do this, I need to execute a very standard API management service that doesn't seem to work well anymore, because if I do this, I get back a very, very strange message. But if you ignore these trailing things, you can see that, this is what I've sent in. If I do just this one, it becomes, an invalid message. And I send it, and presto, I get back a bad request. And if you look down here, it says, it's from the application gateway. So it's not even touched my API, it's just stopped there, which is super cool, I feel. So, Michael, is there anything else you want to show the nice people? Nope. Not right now, at least. So let's see, this is the thing Yeah, everyone knows I'm looking for logging, and moving on. Why is logging so powerful? I'm going to do that, I think. All calls to your things log. Even the query string. And that's the reason why you should never ever place the API key in the query string, because query strings are available. So they can be logged by anyone intercepting that call, all the way from the person's user, the phone or whatever, to your API. Always use the headers and HTTPS, and at least it's encrypted. So that's the thing. You can see what rules fired or misfired, because you might have a caller saying, well, I'm trying to use your API, it doesn't work for me, I only get back at 502, blah, 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 blah. And you can see, oh, this is because you're firing this thing, you need to add this header here because I need it. And you can do things like, yeah, there we go. You can also, since you have a lot of data, you can query that data for things like, how's my SLA doing at the moment? How are my backends reacting? How are they feeling? And you can also use all kinds of creating logins to trigger alerts. I used to do a demo where if someone sent in an order exceeding X amounts of euros, I created an alert that sent out an email to the manager. Just to see that that's one way of doing it, but you can do other things as well, like the number of very strange calls from the same IP address during the last hour has increased by 50%. Please let everyone know this. But you can't do logging without having the data. And this is, of course, then supplied. Otherwise, I wouldn't do a demo. So let's see if I have it here. So this is the log. Once again, I'm not expecting you guys at the back to see anything. But this basically is, this comes up every time you start your log, and it points to a community GitHub repo, which basically means that if someone finds something very useful, they can, make a pull request and everyone gets updated. But you can also do things like saving. If you have a very clever query, you can save that query, which I did by doing a thing called blocked requests here. So if I run block requests, it's getting my data for the last 24 hours. And there's not a lot of data because, I'm not running the super duper popular API here. I'm actually trying to, be a bit covert. But looking at this thing, which is log, I'm not going to go through everything, but you can see that there is a category called application firewall log. you can see what they were trying to call and what they were basically, why were they denied. And in this particular case, it said, the body sent was not a JSON body, although he said it was a JSON body, it was not. That's what this means, basically. But what you also can do, I think if we do this and do a run, you can look at a thing called the request URIs here, and you can see what are people out there trying to hammer on. Usually when a new IP address is visible to the bad guys, what are they trying to access? So they're trying to see if they can log into your, and it says OWA, which is Outlook Web Access Client. So, and they're also trying all kind of different things with PHP, of course. And all these have, of course, automatically been blocked. I can do other things here as well, but I'm not going to show you other than, I think, just let's go with, incoming requests per hour. And the reason I wanted to show you this is because you get a pretty graph. This is your usage. You can take this graph, you can send it in an email, you can export it as something that's consumable by especially BI, Power BI, of course, so it can be used and reused again. And someone that understands data better, perhaps than you and I, can do something useful with it. So let's see, where am I? Yeah, we're going to go through OAuth. So let's see. And while you load up, I'm going to load up. Who in here tried OAuth the first time and said, well, that was easy? No, I thought so. OAuth is a bit of a thing, and I'm going to explain it to you. How am I doing on time? What's the time?
3 minutes to 12.
Which means that I'm way ahead of schedule, which is awesome. You guys get to finish, I get to finish early. You have your API key. This very super duper cute little thing out here is the owner of this API key, or is it this one? That's what I said earlier, right? So you have no idea if it's a cute cat or Karen who's trying to call your thing because they only reused this thing here. So we need to add an additional layer to protect ourselves. Now, a bit of a thing here first. If you are running your APIs in order to make money off of them, it's someone sends you money, so you send them an API key. It's in their interest to keep this API key safe. And if they overuse it, you simply bill them, and it's kind of not your problem, right? So, I mean, this might not be for you. If you're, however, using your APIs in an enterprise environment, you are, and you might have APIs that's called employee, and you can update employee data using these APIs. Those APIs need to be protected. If you have those APIs, this is you're the guy or girl I'm speaking to. So, like I said, the first time you tried OAuth, I used to have hair, and then I started looking at OAuth. It's eye-wateringly hard the first times. It's a lot of things like clients and its IDs and its objects, and everything's are GUIDs. And you start to hate your life and regret decisions. So I'm going to walk through the process and explain, at least say, why is this a good thing from an architectural thing. So if you have your service and it wants to talk to your API. However, you have now protected yourself using OAuth. And in order to make that thing happen, the API must talk to the issuer. In this case, it's your Azure AD. Azure AD, yeah. Yeah, that's the thing it's called, Michael. Why you? And within this Azure AD, someone has configured the Azure AD to say, if this guy calls, let him in. Provided he has, it's a lot of he. I'm going to say she now. She calls, and the only thing she needs to provide is, something called a client ID, which is a GUID, but it's, it's kind of like a username. And then it's a client secret, which is a long auto-generated password. So it's a key. Yes, it's shared, but it's a password. People can handle passwords. API keys, not so much. So they log in and they say, yeah, I want to talk to this guy. And the API says, yes, the API, Azure ID says, yes, here's your token. You can have your token here. It's actually called a JOT token or JWT token or a bearer token, kind of depending on who you are. And it sends into to our service. And our service says, well, to me it's a string of letters. I'm going to ask the guy here, is this yours? This token? And the reason why we do this is, of course, because, we have to validate it. And the way the Azure AD can validate it is that everything is signed using a private key, which only your Azure AD knows about. And a signature, if you ever work with messaging, is, you take the whole message, you do a bit of a calculation on it, and then you add the encryption to that thing. So this means that if someone, I'm going to go through that later, so I'm not going to go into details of that. So I basically say, hey, is this yours? And it's a reply back, yeah, it's mine. You can do what you want with it. And you say, well, good. Then you can talk to my function. I usually equivalent this to you arriving in a new country, let's say Mexico, and you pull up, they say, hey, stop, you can't come in here. You have to present something. You have to present a passport. You have to present your token. And the customs guy looks at this token and says, well, it looks okay. According to my view, it looks okay. You haven't been to Israel lately, have you? No problem whatsoever. Good. You can please come in. You present your passport and you can enter our country. If I approach the customs guy and have a napkin that says, my name is Michael, can I please enter? They look at this token and say, well, I don't really think this is a valid token. It's the exact same thing. The super duper upside for you as an API guy is that you don't have to build squat about that within your API. You only need to add a thing where you say, no, in order to get in here, you have to show these credentials. How those credentials are obtained, updated, managed, not your problem. Which as an API developer is super cool because I can develop something, put it there, and then it's up to like the ops guys to add people into different, Azure AD groups or whatever in order to call my API. Super cool. I love it. So let's do the dreaded demo for the OAuth.
Just a quick question.
Yeah.
Normally the relying party doesn't call the identity provider, but is this different?
Normally the relying party doesn't call the identity provider. Yeah. There are a lot of different ways of implementing OAuth. Yeah. This is the way that I see mostly implemented and the thing I learned. There's also a whole problem about being able to intercept the token and use that token, which you can then do things with, like introspection and so on and so forth. However, I'm not going to go into those details, basically. There is a way to look at and decrypt the token within Azure, within API management, and you can of course do that in code if you want to. This is just much more easy, according to me, because I'm going to show you, but send it somewhere, they do the work, I don't have to do anything. So we're going to end on tips and conclusions, obviously. So where am I now? Well, I'm going to take a look at calling different APIs, I think. Not exactly sure when I'm supposed to start right now, so let's see. Well, I am going to start in my Azure API Manager. This is the configuration. If you haven't worked with Azure API Management before, it's kind of XML. You can either like it or love it, it doesn't matter, it's there. And this is the unauthenticated thing. It's basically saying, call that backend service I configured earlier, which in this case is an Azure Logic app. And also create make sure it's a post, and add this header and then add this body, because Logic Apps developers default to post because it's much easier for them, although the API doesn't update anything, so therefore we do a get, right? So that's the reason. This is the thing, it works. I'm going to show you because, of course, call API, that's the thing I did before, current weather in Stockholm, so on and so forth, blah, 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 blah. Yeah? And then we take a look at what's needed for the secured thing. So, hey, it's over there. You can kind of read it at the back, I think, right? Sure. But I'm still going to read it out loud to you. So this is the thing that was there before, and these are the things that I added on top of it. Note that I'm still using the API key on top of the OAuth. So that's way before in the calling structure, but I'm still using it because, I mean, why not? Why not add that very easy, maintainable security thing? It's also a very good way of, never mind. So I'm basically saying this. Thank you, Alan. So I'm looking in the authorization header for something, and I'm going to send that to this thing here. It's called an OpenID config URL. And it's, hey, look, there's another GUID, and it says something about OpenID configuration. I'm going to go through this. And I'm going to look for something in that token that's called an audience, and I want that audience to be this. Say, look, there's another GUID, and that audience basically means me. You want to speak to me. And then I also want to make sure that whoever issued this is an issuer that I trust, which is like me. It's permobil.com. This is the issuer. How do I come across about these things? Well, you have a thing called your Azure AD here. And this is way too small. Let's see if I can do anything with it. Stop. Thank you. You have app registrations. And for every, the easy thing is that you have one app registration, which is basically your API platform. And let's not go further there. And then you can have API app registrations, which are your different callers, your different calling services, or different calling apps, or whatever. And I mean, you should usually have like one per calling system. So what I've done here is that let's see, it must be this one. So I created it. It's super simple. It's so simple that I even made a blog post about it. It's just super easy walkthrough. And I would like to see if I can find this expose the API stuff. Yeah, this thing, I think, yeah. So I said that, well, this app exposes an API, so therefore it gets this application ID URI, which is the thing which I put here. So if someone sends me an auth token with this one, he wants to speak with me. That's the first thing. And the other thing I did was that I also configured the caller. And the caller needs some additional information. It needs these IDs, which I talked about earlier, but it also needs a secret. So I created one called Cloudburst. And it will expire tomorrow. That's why it's marked at this. And this is the password for that user or that caller. And it's very, you simply say create new client secret, and then you transport that secret securely somewhere so they can use it. That's the thing you need. So this is the identity of the caller. Really wish they would make this feel a bit more user-friendly. But this is what we got so far. So if I need to call this called the secured API, so the difference is that it says current temp secure up here. And if everything works like it should say, I should do this. So now it's trying to call it just using the API key. So if I call it, I should get back a, unable to validate JWT token. This didn't work at all because I haven't supplied it. How do I get the token, you say? Well, what you do is that you issue a very specific request to a very specific endpoint. This very specific endpoint, I'm going to just tell you guys that this is a GUID. That GUID is the same as for permabuild.com. So it's only we that get to use this thing here. So if I send something here, what do I send? Well, first of all, it's a form data body, which is, kind of old school. And you send in the client ID and the client secret. This is the client ID of the caller. You send in the client secret, which is generated earlier. I say, I want to speak to this particular API. I want to speak to this thing, and I'm using something called a client credential. If I send this, I get back what's called an access token. This is the bearer token. It has a couple of things embedded in it. It always starts with EY, which I kind of feel it says A every time looking at it. So if I copy this, and I learned this too late in life, that is, it's not encrypted in full. You can read that data. It's no problem. You just go to a site called .ms, for instance, or .io, and you paste it, and it decodes it for you. And once again at the back, I'm just going to read it out to you and say, well, what does it do? Well, it has something called AUD, which is audience, which is the GUID I asked for earlier. So this is valid for that particular thing. I also asked the issuer, which is this value here. And it also says something like signature. And this is relating back to what I said earlier. If someone intercepts this token, it's only valid for, in this particular case, I think it's an hour. That's the first thing. But if you intercept it and you update it and you say, well, I want to be able to access this forever until end of Unix time, then you mess up the signature, because the signature is, a calculation based on the entire body, the way it looked, and then privately signed, which means that if you update any of these, it invalidates the whole thing. So it's secure in its state. But remember, once again, if you send a JOT token as a header, it's still, if they have access to a header, so you can still read them. But if we take this, we go back to our wonderful postman. Who hasn't done this? So let's see if I can get, no, I can't. I'm not usually working like this. So what you do is that you add a test. Tests are executed after the request has come back. And you say, well, if the response was 200, i.e. I got back a token, I set a collection variable called OAuth token, which is the thing that's out to the right here. So instead of taking that entire token, pasting it somewhere manually, this is updated constantly. So this thing here is set. Let's see if I have it. There we go. So in Postman, you can basically say all these calls beneath, this folder should use this authentication. And in this case, I'm saying use bearer token and use the token which is stored in this variable, i.e. the variable I just updated, right? So if I look at the call secure API, and instead of trying to using the API key, I go say, well, inherit from parent, i.e. the thing I just looked at, and send it, I get back the temperature. Woohoo! Now it's secured, but we can still access it, which is super awesome, because we can also take a look at the thing here which I sent. And you can all see that it's got quite a hefty authorization stuff in front of it. So this thing, you still have the API key, but if you add on top of that all the other stuffs, then it becomes kind of tricky to just hijack something, because then you need to hijack the API key, yes, but you also need to hijack their login credentials. And if you do hijack the login credentials, they're mostly worth their salt for about an hour. I have no idea how you would go about to do that, but I mean, resilient architecture is kind of big thing today. So I'm going to mention it. It might be Lizard. And I think by that, I realized I forgot something, but I'm just going to end it anyway. Because, hey, everyone can read, Michael, why do you do this? You know, instead, oh, I'm gonna hide it, and then I'm going to slowly reveal it anyway. So, tips and pointers for doing things, working with these kinds of products in Azure, because I've done it for about 2 years. And it's super duper good. It's very convenient if you do it in a good way. One, a gateway can be reused, unless it depends. So a gateway and the firewall costs about 500 Swedish crowns per month, I think. And I mean, that might not be super duper steep, especially when it comes to things like security. They tend to cost in the thousands and thousands and tens of thousands to do basic things. However, if you need to have what's called a CNAME address, so if you need API.permobil.com and then have API-test.permobil.com, that's different CNAMEs, and therefore you need two different identifiers, and then you need two different gateways. Or you need to do stuff like, I want to host HTTPS on port 444, which tends to, you know, all kinds of alarm bells. However, if you instead opt for, say, api.permobil.com/test address, or api.permobil.com/prod, blah, then it's a routing rule, and you can still reuse the same thing. So, I mean, it affects the way you decide how, should I use a CNAME or not, that has a direct corresponding with how many gateways do you need. So just think about that. I've always used 3, and here's the reason. It's great to work with infra and ops guys if they do what you say, or you know, vice versa, because the gateway is usually part of the infrastructure, because that's the way they view it. It's like, this is kind of network related. You say the word firewall, it's mine. I'm hosting this. Okay, cool, no problem whatsoever. I even set up everything that I do currently in Bicep, and then had the misfortune of having to learn YAML over the course of about 2 weeks in order to, you know, push everything to different environments. Hate YAML, it's the worst programming language ever, especially the tooling. So what you do is that you have 3 different environments. You have a development environment, that's your environment. You develop your APIs, and then you want to update the application gateway in some way. So you have a development environment where you can do everything. And what we did in one project was that we updated that thing. We updated especially the routing rules when we published a new API and said, well, Guy, on email, please update the test environment. So he can log into our development environment, follow the laundry list that we sent him, take those changes and update his script, which in this particular case was Terraform. And he published that to test, and if everything worked okay, then, you know, it's in the CI/CD pipeline. The same thing is also going to update the production when we go into production. So our test environment was his kind of dev environment. That's a good thing. You can do a really cool thing with Key Vault, which I don't know why I'm like 47 years old before I realized this. Using star certificates is very, very finicky and very, you know, people don't like them, because if you have a star certificate, you basically have the key to the company. You don't want to put them everywhere, and especially with that certificate, you usually have a password, because that's the way you install it, that's the way you do it. If you have the password and the thing, well, you can do all kinds of crazy nasty stuff, right? So you don't want anyone to get the hold of those two together. What you do with Azure Key Vault. Why do you install it in Azure Key Vault? Because every product worth its salt uses Azure Key Vault to pull certificates from it. You don't install that directly into the product. You used to do that, stop doing that. But what you can do with Azure Key Vault is that you add that ops guy to people that are allowed to access, people that are allowed to install stuff. He installs the stuff, he copy pastes things from LastPass or whatever into his portal and clicks install. He says I'm done. I remove him, and the certificate is there. It's installed. I can use it. I can never access that private key password. So it might be a simple thing. I just last week it was like, why don't we do this instead? What have we learned today? I'm going to go into this thing here super quickly because I want to know what I learned today as well. So I want to know what happens. Your APIs may be at risk. If you are using only API keys on top of APIs that exposes GDRP related data, please add additional functionality to it. Add layers of security. You can add layers. You don't need to go all the way out to, you can do OAuth without having a gateway. Of course, no problem whatsoever. But you can also have a gateway without using OAuth. You can have a gateway without using the firewall thing. It's layers of security. Everyone should look into what OWASP is and what they do. If you didn't know and do API development or publishing, you have a bit of homework during the weekend, and try to move away from a scenario where you only use API keys as the sole thing. And as ever, smart people have been thinking about these kinds of issues for quite a long time and done, presented products in Azure for you. So Azure is there for you to, live out your security dreams, as it were. And I think that's the end of my talk.